Math 1143, Test 3 Review Sheet, Chapter 3 Material, Section 3.5. We'll solve this exponential equation. 3 to the x plus 1 equals 4 to the 2x minus 5. So we'll just take the natural log of both sides so that we can get the variables out of the exponents. Natural log of 3 to the x plus 1 equals the natural log of 4 to the 2x minus 5. Bring the exponents out front. The exponent is a binomial, so put that in parentheses. X plus 1 times the natural log of 3 equals the binomial 2x minus 5 times the natural log of 4. Then apply the distributive property on both sides, so we get x times the natural log of 3 plus 1 times the natural log of 3. On the right-hand side, 2x times the natural log of 4 minus 5 times the natural log of 4. So we're solving for x. We want every term with x on one side of the equation, every term that doesn't have x on the opposite side. So I'll just subtract 2x times the natural log of 4 from both sides and also subtract the natural log of 3 from both sides. So doing both in the same step, we get x times the natural log of 3 minus 2x times the natural log of 4 equals negative 5 times the natural log of 4 minus the natural log of 3. And then on the left-hand side, we factor x out of both terms, so we get x times the quantity, the natural log of 3, minus 2 times the natural log of 4, equals the right-hand side, negative 5 times the natural log of 4 minus the natural log of 3. And then finally, divide both sides by the natural log of 3 minus 2 times the natural log of 4. So in the numerator, negative 5 times the natural log of 4 minus the natural log of 3, all divided by the natural log of 3 minus 2 times the natural log of 4. Okay, in the next equation, we have an exponential equation. 0.3 raised to the x minus 2 equals 0.8. So in step 1, add 2 to both sides. So we get 0.3 raised to the power x equals 2.8. And x is in the exponent, so we'll take the natural log of both sides. The natural log of 0.3 to the x equals the natural log of 2.8. And then using a property of logarithms, the exponent x is brought out front, so it's x times the natural log of 0.3 equals the natural log of 2.8. And then finally, divide both sides by the natural log of 0.3, and x equals the natural log of 2.8 divided by the natural log of 0.3. Okay, so the next equation, solve log base 2 of x squared plus 2x equals 3. We'll convert this logarithmic equation into its exponential equation equivalent. The base number 2 raised to the exponent 3, 2 to the third, equals the argument of the logarithm x squared plus 2x. So we just get a quadratic equation, and so we'll subtract 8 from both sides because 2 to the third is 8. So we get 0 equals x squared plus 2x minus 8. And we can easily factor that. 0 equals x plus 4 times x minus 2. And the two solutions to the quadratic equation are x equals negative 4 and x equals positive 2. Okay, but the goal is to solve this logarithmic equation. So we should test to see if those numbers actually work. Okay, so when x is negative 4, we get log base 2 of the number negative 4 squared plus 2 times negative 4. And negative 4 squared is 16, and plus 2 times negative 4 is 8. So this is the natural log of 8. And sorry, not the natural log, log base 2 of 8 equals 3, and 2 to the third equals 8. So that checks out. When you test x equals 2, we have log base 2 of 2 squared plus 2x. 2 squared is 4 plus 2 times 2 is 8. So we get log base 2 of 8 equals 3, which is also true. 2 to the third equals 8. Okay, in the next example, in a logarithmic equation, log base 6 of x plus log base 6 of x plus 5 equals 2. First, we want to apply the product property of logarithms and write the left-hand side as a single base 6 logarithm by multiplying the arguments x times x plus 5. And that's equal to 2. And then we'll convert the logarithmic equation into an exponential equation. The base number 6 raised to the second power equals the argument x times x plus 5, and I'll just write that as x squared plus 5x. And 6 squared is 36, so we'll subtract 36 from both sides. We get 0 equals x squared plus 5x minus 36. And we can solve this one by factoring also. One factor is x plus 9, and the other one is x minus 4. This quadratic equation has two solutions. One is negative 9. The other one is positive 4. But you'll see in the original equation, if you replace x with negative 9, the argument of this logarithm is negative. So arguments of logarithms can't be negative. So negative 9 cannot be a solution. When you test x equals 4, that one works. Log base 6 of 4 plus log base 6 of 4 plus 5, which is 9, equals 2. And you can verify that this is true by applying a couple of properties of logarithms. But x equals 4 is the only solution. Okay, in the next example, log base 2 of 5 minus 3x equals 3. So this is all prepared to convert it to its exponential equation equivalent. The base number 2 raised to the exponent 3 equals 5 minus 3x, or 8 equals 5 minus 3x. So we'll add 3x to both sides and subtract 8 from both sides. We get 3x equals negative 3, or x equals negative 1. Well, even though x equals negative 1, when you replace x in the argument with negative 1, you still get a positive argument, because 5 minus 3 times negative 1 is equal to log base 2 of 5 plus 3, or 8. And log base 2 of 8 equals 3 is true, because 2 to the third equals 8. So negative 1 is the solution to that equation. In the next part, this is all set up to apply the equivalence property. Log base 7 of t plus 6 equals log base 7 of 12 minus t. So the arguments must be equal. T plus 6 equals 12 minus t. We'll solve for t, add 1t to both sides and subtract 6 from both sides. We get 2t equals 6. Divide both sides by 2, you get t equals 3. And you can verify by looking that when you replace each t with 3, you'll just get log base 7 of 9 equals log base 7 of 9, and that is absolutely true. In the next example, the natural log of 3x minus 10 equals the natural log of x minus 4 plus the natural log of x. So first we write the sum of the logarithms on the right-hand side as a single natural logarithm by multiplying the arguments x minus 4 times x. And now that we have a single natural log on each side, the arguments are equal. So the argument 3x minus 10 is equal to x minus 4 times x. I'll just write that as x squared minus 4x. And we'll subtract 3x from both sides and add 10 to both sides, and we get x squared minus 7x plus 10. And we can easily solve this by factoring. X minus 2 and x minus 5 are the two factors. And the solutions are x equals 2 and x equals 5 for the quadratic equation. But we're solving a logarithmic equation. When you check x equals 2, in the first logarithm, 3 times 2 is 6, 6 minus 10 is negative. Arguments of logarithms can't be negative, so x equals 2 is not a solution. The other one, x equals 5, replace every x with 5 and all of the arguments are positive, and then you can verify that the equation is true when x equals 5, but x equals 5 is the solution. Okay, in the next part we have a couple of word problems. Number 2, if $12,000 is invested and earns 8.5% interest compounded continuously, we're assuming that it's an annual interest rate, determine how long it takes for the money to triple. So first we'll write down the function a equals the principal 12,000 times e to the 0.085 times t. This is the function. The value of r is 0.085. So find the amount of time it takes for the money to triple. So at some point in the future, the amount will be 3 times the initial amount. So 3 times 12,000 is 36,000. So you set 36,000 equal to 12,000 times e to the 0.085 t. And then divide both sides by 12,000. 36,000 divided by 12,000 is 3. So 3 equals e to the 0.085 t. Then take the natural log of both sides. The natural log of 3 on the left-hand side equals the natural log of e to the 0.085 t on the right-hand side. But the natural log of e to the 0.085 t is just 0.085 t. And then we just divide both sides by we divide both sides by 0.085. 0.085 equals t. And then you can use a calculator to determine a meaningful answer for the number of years it takes for the investment to triple. Okay, in the next problem, suppose $10,000 grows to $13,178.48 in 3 years under continuous compounding of interest. Find the interest rate. So first we'll write the function. The initial amount is invested is $10,000. We don't know the interest rate, so we'll write 10,000 times e to the RT. But we are told that when t is 3 years, the amount is $13,178.48. So we can solve for r, just replace a with $13,178.48 equals 10,000 times e to the 3r, because we're replacing t with 3, and then divide both sides by 10,000. If you divide 13,178.48 by 10,000, we can just move the decimal over, so we get 1.317848 equals e to the 3r. And then take the natural log of both sides. So the natural log of the left-hand side is the natural log of 1.317848 equals the natural log of e to the 3r, but the natural log of e to the 3r is just 3r. So all we have to do now is divide both sides by 3, so the natural log of 1.317848 divided by 3 equals r. That's the interest rate. Use a calculator. You can get a decimal number that makes sense, and you can convert it to a percent for the annual interest rate.